Overview. The RJ cockpit is centered around 4 Efis screens, 2 for each pilot. Each pair of Efis screens is driven by a dedicated symbol generator. Each pair of Efis screens has its own cooling fan. The screens provide information from the IRS system, the GNSX system, the 2 VOR ILS DME systems, the 2 ADFs, the 2 ADCs, the weather radar, the 2 radio altimeters. In the event of a symbol generator failure, all the screens can be driven by the remaining symbol generator. Power to each pair of Efis screens is supplied through their own Efis master switch. A dimming panel, DP, and Efis control panel, ECP, are situated on each side of the flight deck to control the associated displays. An Efis transfer switch is fitted on the captain's side only. The indications and operation of the captain's and first officer's Efis are essentially the same. The following description applies to the captain's Efis. Where differences between the systems exist, these are explained. Each Efis screen has an inclinometer, slip indicator, mounted at the bottom of the instrument. Dimming panels. The dimming panels are situated to the left of the PFDs and contain the following controls. Bright PFD, Bright ND, Weather Control, Decision Height Control, Test Button, Bright PFD. This rotary knob allows the primary flight display to be set between minimum and maximum brightness. With a PFD failure, it is possible to combine both PFD and ND information on the ND. This is achieved by turning bright PFD anti-clockwise through a detent to the compact position. Bright ND. This rotary knob allows the navigation display to be set between a minimum and maximum brightness. With an ND failure, it is possible to combine both ND and PFD information on the PFD. This is achieved by turning bright ND anti-clockwise through a detent to the compact position. Weather Control. A black control knob is mounted on top of the bright ND knob for selection and brightness control of the weather display on the ND. Rotating the knob clockwise from the weather off position through a detent displays the weather information on the ND. Decision Height Control. A decision height setting knob permits the decision height to be set in the bottom right of the PFD. If the knob is turned fully clockwise until it reaches a stop, it is set to the maximum setting of 500 feet. Turning it anti-clockwise reduces the decision height. Turning it fully anti-clockwise removes the decision height altogether. Test button. This is used to test the Efis and the on-side radio altimeters during the flight deck safety check. This will be covered later. Primary flight display. This section describes the information shown on the PFD. Attitude. The PFDs provide aircraft attitude reference supplied by the Inertial Reference System, IRS. The horizon is shown as a white line dividing the brown earth reference and the cyan sky above. Also, radio altitude is shown at the bottom of the display if the aircraft is below 2,500 feet AGL. The aircraft is represented in the center of the display. Either a yellow delta symbol or a grey symbol will be shown, dependent on the airline's choice of flight director. In the rest of this module, the yellow delta symbol will be used. Roll reference is provided by a triangular pointer against a roll scale marked at 10, 20, 30, and 45 degrees on the upper periphery of the attitude display. Pitch reference is provided by a scale marked every 2.5 degrees and numbered every 10 degrees up to 30 degrees. If the aircraft is pitched beyond 30 degrees, red chevrons appear to guide the pilot back towards level flight. In addition, regardless of pitch attitude, the cyan sky or brown ground reference will remain visible in the correct relative position to the aircraft symbol. The wind shear pitch limit indicator is displayed below 2,000 feet AGL as a white moustache. This represents the pitch angle at which stick shake would occur in the present flight conditions. This is useful information in the event of encountering wind shear, where it is sometimes necessary to pull up to the maximum possible safe attitude. What is the attitude of the aircraft according to the PFD? Radio altitude and decision height. Radio altitude is indicated at the bottom of the attitude display when the aircraft is below 2,500 feet AGL. The decision height is shown at the bottom right. For this example, a decision height of 200 feet has been set. Radio altitude display is green unless below the selected decision height, when it will be yellow. The decision height is set using the decision height control on the associated dimming panel. The heights selectable are 500 feet to 1 foot. The decision height is removed completely when the decision height control has been turned fully anti-clockwise. The decision height is removed when radio altitude is blanked, i.e. above 2,500 feet. The decision height can still be set above 2,500 feet, as the display will reappear as soon as the decision height knob is rotated. The display will blank again shortly after decision height has been set, and will remain blanked until below 2,500 feet. The decision height display will start to flash 50 feet before decision height is reached. Once decision height is achieved, the decision height display is replaced by an amber DH, and the radio altitude display turns yellow. Below 10 feet, decision height is removed and rad alt returns to green. Set the decision height to 50 feet before continuing. Airspeed information. The airspeed tape is situated on the left side of the PFD. The speed is shown as an enlarged number halfway up the tape, which is scaled in 10-knot divisions. Normally, the number is displayed in green. With a change in airspeed, the tape moves up or down, and the displayed speed changes accordingly. Mach number is shown below the speed tape whenever the value is Mach 0.4 or over. Below 30 knots, dashes are shown. A magenta speed trend vector line is also shown on the right side of the speed tape. It shows the predicted speed in 10 seconds at the present rate of acceleration or deceleration. A cyan triangular speed-selected V-cell bug is displayed on the right side of the tape and is accompanied by a digital indication of V-cell. This indicates the speed that the pilot has selected on the Mode Control Panel, MCP. Above 100 feet AGL, minimum flying speeds are displayed at the right-hand edge of the speed tape. There are two types of minimum speed indication. The first consists of a red and black tape, which extends from 30 knots to stick-shake speed, which is known as VSS. The second consists of a yellow band, which extends from VSS to approximately 1.2 VS, which is known as Vmin. The airspeed indication will be yellow if flying within the yellow band, and red if the speed is below VSS. Flap and gear limit speeds, VFGL, are shown by a yellow band extending from the appropriate limit to VMO, MMO. In this example, the gear limit speed of 210 knots is being shown as the gear is extended. If the gear limit speed is exceeded, the speed will be displayed in yellow. If the gear is now raised, the limit is removed and the speed will be displayed in green. VMO-MMO is shown as a red and black tape at the top of the speed display. The airspeed indication will be red when speed exceeds VMO-MMO. If the speed trend vector penetrates a red area of the speed tape, the displayed speed and Mach number, if applicable, will change to yellow. Here is a summary of the speed limit regions. Set the V-cell bug to an airspeed of 225 knots before continuing. Lateral deviation indication. Whenever a course is displayed on the ND, a lateral deviation indicator is shown on the PFD. If a VOR has been selected, deviation is shown by a green triangle on a scale of 1 dot per 5 degrees of error from the selected radial. If an ILS has been selected, deviation is shown by a magenta rectangle on a scale of 1 dot of ILS standard deviation. Glide slope deviation is shown to the right of the attitude display. If the localizer back course is being used, glide slope deviation will be replaced by back course shown in white. If LNAV has been selected, deviation is shown by a white diamond on a white scale. Max displacement from center equates to a track error of 3.75 nautical miles. More details will be given on this when we look at the ND. Marker beacon indications. Indications for the marker are displayed in the bottom right-hand corner of the attitude display. An outer marker is displayed as a cyan O. A middle marker is displayed as a yellow M. An inner marker is displayed as a white I. Vertical speed indication. Vertical speed is displayed as a tape to the right of the PFD. The tape has a non-linear scale and is numbered at 1,000 feet per minute and 2,000 feet per minute. The current vertical speed is indicated by a green pointer with a number beside it representing hundreds of feet per minute. The pointer will carry on reading past the scale to give a full range readout. Should the vertical speed exceed plus or minus 6,000 feet per minute, the numerical readout will change from green to yellow. Rates of descent and climb are indicated in the same way. The reversion from green to yellow is modified with radio altitude as follows. Altitude less than 2,500 feet AGL with vertical speed more than -2,000 feet per minute. Altitude less than 1,000 feet AGL with vertical speed more than -1,500 feet per minute. If TCAS is fitted, resolution advisories are displayed on the vertical speed tape as green and red segments. In order to comply with the resolution advisories, vertical speed is adjusted to the green arc. This will be covered later. What is the vertical speed of the aircraft according to the PFD? Flight Director. Each PFD has its own Flight Director on-off switch on the MCP. When selected On, the Flight Director is displayed in magenta on the PFD. There are two possible Flight Director symbols, V-bar or crosshairs. They are not pilot selectable but depend on airline option. For this CBT, the V-bar option has been chosen. Mode indications. Flight Director and Autopilot modes are indicated at the top right of the PFD display. Modes are selected using the push buttons as shown on the MCP. When AP is shown in green, the autopilot is engaged and the modes displayed apply to the autopilot, and Flight Director if selected on. If FD is displayed, the autopilot is not engaged and modes indicated apply to the Flight Director only. All Flight Director and autopilot modes are shown in green when engaged and white when armed. If neither autopilot is engaged or a Flight Director selected on, no modes will be displayed. Thrust modes are shown at the top left of the PFD display. If AT is displayed, the auto throttle is selected. Indications are shown in white for an armed state and green for an engaged state. Why is the rad alt data displayed in yellow? What will the airspeed be in 10 seconds time? Navigation display, ND. In this section, you will become familiar with the information displayed on the ND and will learn how to control the display. Heading information is provided by the on-side IRS and is normally magnetic, but can be selected to true by moving the guarded heading switch to true. The ND is controlled by the pilot's respective Efis control panel on the pedestal. There are 4 format options available via the Format knob: Rows, Arc and Map are en route navigational formats, whilst plan is used for planning purposes. Each of these formats will be covered in greater detail in the following sections. Rows. The rows format is the simplest display, but it offers the least situational awareness. Selecting Rows on the Efis control panel will display a compass rows with present heading shown under the inverted triangle at the top of the display. The selected heading is shown as an inverted cyan M on the outside of the rows. This is repeated as a digital readout on the top left of the display. Heading is selected by rotating the heading knob on the MCP. A green diamond on the scale shows present aircraft track when airborne. The bearing control enables the selection of bearing information to either the on-side ADF, VOR, or next LNAV waypoint. Confirmation of bearing source is given on the bottom left of the ND as ADF, VOR, or WPT in green. The display is a green needle which is solid in appearance on the captain's side and is hollow on the first officer's side. It is not possible for the captain's side to display the first officer's VOR or ADF bearing and vice versa. The Efis control panel range control has no effect in rows. However, range is available in other formats and will be covered later. Navigation data is selected from the Efis control panel navigation data key by depressing the button. This will allow display of ground speed, wind speed and direction, distance to next waypoint, ETA at next waypoint. A white light below the key indicates that data has been selected. The course knob is used to select the primary navigation course from OFF to VL or LNAV. The course pointer and deviation are displayed in the centre of the ND, with the associated nav source in the top right. With VL selected, VOR or ILS primary course information is displayed. With LNAV selected, LNAV primary course information is displayed. With VL selected and a VOR frequency tuned on the VHF nav controller, course information is displayed in green. This consists of a pointer and deviation bar aligned to the course set on the course selector knob on the MCP. To indicate the navigation source, VOR1 is displayed on the captain's ND and VOR2 on the first officer's ND. To or from indicates whether the aircraft is flying to or from the selected VOR. The deviation scale consists of 4 white dots. Each dot represents a 5-degree error from the selected course. The co-located DME distance is also displayed on the ND in green. With VL selected and an ILS frequency tuned, course information is displayed in magenta. To indicate the navigation source, Lock 1 is displayed on the captain's ND and Lock 2 on the first officer's ND. Each dot of the localizer and glide slope scales represents a conventional ILS deviation. An associated DME distance is displayed on the top left of the ND in magenta. To display LNAV as the primary navigation source, the course selector is moved to the LNAV position. The course pointer and deviation bar are now displayed in white. The course displayed will be provided by the GNSX. The MCP course selector has no effect. The deviation scale is 1 dot per 3.75 miles course error. DME distance is replaced on the top left by distance to the next waypoint in white. LNAV1 or LNAV2 is shown at the top right of the respective screen in white to confirm the source of the navigation information. The second course button provides secondary navigation information. The display consists of a course pointer and deviation bar in cyan. The deviation scale dots, offside DME, or distance information cannot be displayed. The second course navigation source is shown in cyan at the top right of the ND. Successive presses of the second course button display the possible second course selections dependent on the primary course in use. A final press removes the information. Use the second course button to display all 6 second course options before continuing. What is the aircraft's present track? Arc. Arc is selected by rotating the Format knob to the Arc position on the ECP. The Arc display is essentially the same as rose, except that only the forward 110 degrees of the compass rose is displayed. The compass segment is expanded to enable greater accuracy. If course and bearing pointers are shown, they are expanded to fit the new display. The heading bug has a dotted cyan tail to enable its bearing to be seen, even if selected outside the visible arc. Remember, the heading bug is adjusted using the Heading Select knob on the MCP. Weather radar information can be displayed in ARC. Weather radar information is selected on by rotating the black weather knob on the dimming panel clockwise through a detent. Weather radar mode and tilt information is shown in cyan on the left of the display. Mode and tilt indications are selected on the weather radar unit. This will be covered later. Radar range corresponds to the range selected on the ECP. A white range arc is displayed at half the selected range. Now change the range to 80 miles. Weather radar information can also be displayed in map format. Map. The map format clearly indicates the horizontal situation of the aircraft. The aircraft is shown as an RJ symbol near the bottom centre of the screen. The displayed compass presentation and heading bug are shown as per arc. The green track diamond is shown as per rose and arc. Bearing selections operate as per rose and arc. Select ADF bearing. The range control is now available regardless of radar selection, and the white range arc is always shown on screen. The data key operates as per rose and arc. Use the data key to select wind speed and direction. Navigation information is shown differently from rose and arc. With the course control selected to LNAV, the active GNS flight plan appears on the screen. In flight, providing the aircraft is on track, the waypoints of the flight plan pass below the yellow RJ symbol. The active waypoint is shown as a magenta star and all other waypoints as white stars. LNAV 1 or LNAV 2 will be displayed on the respective ND, and distance is shown at top left as per rose and arc. Radar information is shown in the same way as in arc format. However, because the LNAV flight plan track is also shown, the position of storm cells in relation to the intended flight path can be clearly seen. With the course control selected to VL, the active GNS flight plan is not shown. Combined VOR-DME beacons are shown as a green Vortac symbol in the correct relative position to the aircraft symbol. The Vortac has a solid green course line drawn to the station and a dotted green course line drawn from the station. Select VOR bearing. If the beacon selected is outside the ND selected range, the to from course line is visible accompanied by a green arrow pointing towards the beacon. The beacon can be brought back into view by increasing the range. If a DME is not being received, the display reverts back to a course pointer and deviation bar as per the ARC display. The display of ILS information is always a course pointer and deviation bar in magenta. Glide slope is not displayed on the ND, but is still available on the PFD. Just as in ARC and ROSE, VOR1, VOR2, to from, or Lock 1, Lock 2, is shown at the top right of the respective ND, and DME distance is shown at the top left. The second course button provides the same selections as per ARC and ROSE. All second course indications are in cyan. If LNAV is selected as the second course, the GNS flight plan, including active waypoint, is shown but in cyan. If a VOR is selected as second course, the Vortac symbol with course line is shown. If no DME is available, the display is a course pointer and deviation bar. If ILS is selected, a course pointer and deviation bar is shown. Confirmation of the second course selection is shown at the top right of the ND. Map format allows the use of NavAid, Airport and GRP keys on the ECP, providing LNAV is selected as primary or secondary course. The keys are of the on-off type, and a white light illuminates below the button when it has been selected. Any combination of keys can be selected. Selecting NavAid displays the 10 nearest navigation aids within the selected range held in the GNS database. The navigation aids are shown as an IKO symbol and identifier in cyan. Selecting Airport displays the 10 nearest airports within the selected range with a runway distance of 5,000 feet or more. The airports are shown as a white circle. Selecting GRP displays the nearest ground reference points within the selected range. The GRPs are shown as a triangle in cyan. Summary. All the following navigation symbols can be selected in Map. What is the range of the midway point? Approximately what VOR radial is the aircraft about to cross? Plan. Plan is selected by rotating the Format knob to Plan. Plan is used during pre-flight planning and reroute planning only. As a result, the following navigational information is not available: VOR ILS course and deviation, all second course information, bearing information, weather radar, data button information. The dotted cyan tail of the heading bug is removed. The compass arc is shown as per arc and map. The green track diamond is still displayed. The range control works in the same way as in map format, but instead of a half-range arc, there is now a range ring in cyan. The LNAV flight plan is displayed north up, with the active waypoint in the middle of the display. The aircraft now moves along the flight path. Confirmation of the north up display is given as an arrow with an N above in white. With LNAV selected, distance is shown in white at the top left of the ND, and LNAV 1 or 2 is shown on the respective ND. NavAid, Airport and GRP are available as per map. Because of the lack of en route navigation information and the north-up LNAV display, the plan format should be used for flight planning and rerouting only. What is the approximate heading to the EGC waypoint? Miscompare detection. The Efis provides warning of miscomparison between parameters presented on the left and right Efis displays. When a miscompare is detected, a warning flag is displayed on both the left and right Efis displays. In order to bring a miscompare to the attention of the flight crew, the comparator master annunciator is also displayed on both instrument panels. When first displayed, the miscompare and comparator master annunciators flash for 5 seconds before coming steady. If a new miscompare is then detected, only that warning and the comparator master annunciator flash for 5 seconds, alerting the flight crew to the generation of a new warning. The following signals are monitored. Attitude. ATT is displayed when a difference of 4 degrees in pitch or roll attitude is detected. Heading. HDG is displayed when a difference of 6 degrees plus 1/3 of the current bank angle is detected. Speed. SPD indicates a detected difference of 8 knots at low speed, decreasing to 3 knots at high speed. Radio altitude. RA indicates a detected difference of at least 10 feet, dependent on average radio altitude. Localizer. LOC, displayed on both the PFD and ND, indicates a detected difference between both localizer signals of 0.4 dots plus 0.25 times the average localizer deviation. Glide slope. GS, displayed on both the PFD and ND, indicates a detected difference between both glide slope signals of 0.53 dots plus 0.25 times the average glide slope deviation. The relevant indication is removed when the miscompare condition ceases. A miscompare warning is normally the first indication of an instrument or radio navigation system failure. Following the failure of a system which is monitored by the miscompare system, the miscompare warning is only displayed on the good side. A failure flag is displayed on the side of the failure. Failure flags will be discussed later in this module. Miscompare failure. When a failure of the Efis monitoring system is detected, comparator is displayed on the PFD. Miscompare test. The Efis miscompare function is tested when the flight annunciator test button is released after performing a flight annunciator check. All of the miscompare, comparator master and comparator annunciators are illuminated for 5 seconds and then disappear. Press the test button to observe the test. Efis fail flags. Following the failure of any system providing information on the Efis screen, the relevant display is removed and is replaced by a failure flag. Here are examples of the fail indications. The system failures are covered in detail in the relevant section. Click on each heading below to view the corresponding fail flag. IRS failure. ADC failure. Failure of FGS-derived data. Failure of the flight director. Failure of the TCAS system. Failure of the radio altimeter above 2,500 feet. Failure of navigation source. Bearing failure. Failure of the weather radar if selected. Failure of data information. Efis fail flag test. The fail flags can only be tested when the aircraft is on the ground with the park brake on. The test is performed by pressing and holding the test button on the dimming panel on the relevant Efis. The Efis replaces all of the currently selected information with the relevant fail flags, except for the radio altimeter, which shows a test altitude of 40 feet. Releasing the button removes the flags.
Failure of a symbol generator. With the failure of a symbol generator, both the PFD and ND on one side will blank. The remaining symbol generator is used to supply both pairs of displays. Locate the Efis transfer switch and lift the black guard to gain access. The switch can then be set from norm to both 1 or both 2 as appropriate. If the captain's Efis has blanked, select the transfer switch to both 2 and vice versa.
An indication of SG1 or SG2 will appear in yellow at the bottom left-hand corner of both PFDs.
This indicates which symbol generator is supplying both pairs of Efis screens. Failure of a single Efis screen. With the failure of a PFD or ND, the appropriate control dimming knob should be selected to compact. This will display a compacted format giving both PFD and ND information. With a failure of the PFD brightness control on the DP must be selected to compact. The compacted display is then shown on the ND. In order to show a coloured compact display on the ND, the weather radar must be moved clockwise through the weather off detent. With a failure of the ND brightness control on the DP must be selected to compact. The compacted display is then shown on the PFD. It is important to note that not all the features of the normal displays are available. Format is defaulted to a half rose display. Other formats are not available. A reduced course pointer and deviation bar is displayed. Weather radar, bearing and second course are not available. When the display is compacted, RAD alt and the primary navigation source annunciation are relocated. Failure of a dimming panel. With the failure of a DP, the associated screens will default to full brightness. No pilot action is possible. Failure of an Efis control panel. The ECP is continually monitored for a failure of any of its controls or operation. Should any fault occur, all ECP-controlled information will be defaulted to the following conditions. If an ECP fails whilst compact display is in use, only the course will be affected. Course will default to VOR-ILS. Failure of an Efis fan. With an Efis fan failure, left Efis or right Efis will be enunciated on the avionics cooling fans panel. Efis IRS will be enunciated on the overhead air conditioning panel. Pressing the enunciator will reset the sensing system, PTR. If the fan is serviceable, the warnings will extinguish. If the enunciator remains illuminated, there is a genuine fault and the brightness level of the display must be reduced to decrease heat. Assuming both Efis master switches are selected on, what is the correct pilot action if both the co-pilot's Efis screens blank?